Bismillah ar-Rahman ar-Rahim. Let's look at this problem. This is, I think, OC, I don't know, one of them. I think it's OCW8. Let's look at FB. FC X is 9 meters and Y is 10. And X and Y and Z. Z is 15 meters. Okay, what is needed is to find the force B in Cartesian format. He gave you the magnitude of FB. The first thing we do is to find the coordinate A. The coordinate A, it's 0, 0, 15 meter. You can see that it is only in the z-axis and it's going higher in the z-axis to 15 meters. Let's look at coordinate B, because coordinate B, it connects from A to B for the force B. Coordinate B, you could see in the x-axis from the origin, it is 2 meters in the x, and it is also, this is the positive y, and it's also minus 10 in the y. And since the point B is at the floor, it is 0. See? Point C in the X, this one, it's 9 meters. In the Y, this is a positive Y. Since you are in the positive Y, that's 2 meters. And since you are on the floor, it is 0 meters. That's it. We don't need anything else to start this problem. So let me erase this. Okay. So let's start finding the force B. In order to find out the force B, or to change it from magnitude to Cartesian format, you need to multiply the magnitude by the unit vector. Okay, so what we're going to do is to find the unit vector AB. Okay, so how could we do this? How could we find the unit vector AB? Let's find out, first of all, the position vector AB. And that is from A to B. So you're going to do it B minus A. B minus A to I minus 10J minus 15K meters. To I, 2 minus 0, minus 10 minus 0, 0 minus 15. Now, let's find the magnitude. The magnitude is the square root of the position vector, 2 square plus 10 square plus 15 square, and that's going to be equal to, just give me 1 second, let me just go bring the calculator. Hold on. Okay, so 2 square is 4. Plus 10 square plus 15 square, and that is under the square root 18.1 meters. And then you find out the unit vector. 2 over 18.1 I minus 10 over 18.1 J minus 15 over 18.1 K. Here there is no unit. The unit vector has no units. And now you find the unit force AB, which is the magnitude 860 times the first one. So 860 so 860 times 2 over 18.1, and that is 95. 95I minus 10 over 18.1 times 860, and that is 10 over 18.1 times 860. Okay, 475 minus 15 over 18.1 times 860. That's 712.7 K, and that is in Newton. Let me check the first one. 2 over 18.1 times 860. Yes, 95. Okay, so the whole thing is in Newton. Okay, so you could put it here. 95, sorry. 475 and minus 713 K's and J's and the I. Okay, we'll do the same thing for the C. For the force C, we'll do the same thing. We have to find out, first of all, unit vector AC. So we need to find the unit vector AC by finding the position vector. So let's find the position vector AC, which is C minus A, 9I, 2J, minus 15K. The whole thing is in meter. And then you find the magnitude, 9 square plus 2 square plus 15 square. Let's do it using the calculator and see. 9 square plus 2 square plus 15 square, all of them under square root, 17.6 meter. And now the unit vector AC, it's 9 over 17.6 I plus 2 over 17.6 J minus 15 over 17.6 K. Now we found the unit vector. Now we should do the force C. You multiply, this is 380, so 380 times 9 over 17.6 times 380, 194 I, and then 2 over 17.6 times 380, and that is 43.2 J, and 15 divided by 17.6 times 15 divided by 17.6 times 380, and that is 324 minus 324 K. And this is in Newton. So we have the force C, 194, 43.2, and you have minus 3, 2, 4. So we have the force C and you have the force P. Now what is the resultant force? Well, you add up 95 plus 194, and that is 189. You add up 43.2 minus 475, that is minus 432, and then you add up, oh, this is here, they're both minus, 324 plus 713, and that is minus 1037. So in order to find the angles, you need to find the resultant. So you need to find, first of all, the magnitude, which is 189 square plus 432 square plus 137 square. So 1037 square plus 432 square plus 189 square, and all of them under the square root. This would give you the force resultant equal to, this is the magnitude, 1139 Newton. So how could you find alpha? Alpha, which is the angle with the x-axis, is cosine inverse. What is the FRX? 189 over 1139, and that is 1139, and that is times 189, and this is cosine inverse, and that is 80.4 degrees, so this is 80.4 beta cosine inverse minus 432 over 1139. So 432 minus divided by 1139 cosine inverse 32. So the angle is 112, and you can see gamma at the end, cosine inverse minus 137 over 1139, and that will give you 137 divided by 1139, and that is in the minus cosine inverse, and that is 156 degrees. So if you wanna plot that resultant, you can see that this is the x and this is the y. And this is the z. So the force resultant, it is somewhere in the positive x, negative y. So it's going to be somewhere here. So this is the force resultant. And the angles with the x-axis, this is 80.4 degrees. And the angle with the y-axis, 112. Okay, this is 112. And the angle with the z-axis, 156 degrees. That's it for this problem.